So today we're going to be drawing number 42 on page 189. But before we get to that, I want to give you some backstory about our main character of our short word problem. So, the fisherman. This is all about angle of elevation. And the fisherman who decided one day, hey, I'm waking up and I see the sky's blue, the sun's shining, the weather's nice. I think I want to go fishing today because, hey, fishing is my favorite hobby and I'm not going to do my favorite hobby. So, he gets to go out and find a pier, and he finds one, and it looks a little something like this. There's our friend, the fisherman, shaggy hair, his little lunch pail, and so this is him on his pier. Now let's read the problem. A fish is reeled in at a rate of 1 foot per second from a point 10 feet above the water. At what rate is the angle, represented by theta, between the line and the water changing when there is a total of 25 feet of line from the end of the rod to the water? Okay, so our little fisherman, he found the perfect pier, and so he's gonna hold up his pole, and we find out that it's 10 feet from the top of the water to the tip of the pole, this section right here. And we know our fisherman had a pretty good day because he's already reeling in a fish. I mean, we hope it's a fish. We hope it's not like a tire or something, because that would just be disappointing. But anyway, so we found out that he got his line out, he put his hook on his line, put his bait on his hook, and threw it into the water, and he's fishing now, and he's caught a fish. So let's find out how fast this angle is changing, because this is the angle between the line and the water. We're calling it theta, and we're looking for d theta dt, which is the rate at which it's changing. So this is what we're looking for, and we're going to call the line x, and we find out from the problem it's going to equal 25 feet. And the problem also tells us that the rate of the fish being reeled in, so the rate of this line changing, is 1 foot per second. But we have to realize, this little error I wrote here, I wrote this because the line is being reeled in, so it's shrinking. It's getting smaller, and we need to put a negative here because it's getting smaller, so that's just what we do, because we don't want the end of the problem to be crazy and be the wrong sign, because then we'll all be confused. So anyway, let's get to our equation. So we find out that, hey, this makes a triangle, so let's use some trig, because we know trig. And so in coordinates with this angle right here, we realize that 10 feet is the opposite side, and this is the hypotenuse. Opposite over hypotenuse is sine. So we get to here. Sine theta equals 10 over x. Now we need an equation that we can find the variables and plug the numbers in to find d theta dt. So here we go. Theta equals the inverse sine of 10 over x. Okay, now it's time to take the derivative. So the derivative of theta is d theta over dt, which is going to equal this right here, 10 over x. To take the derivative of that, we have a little shortcut that we change the sign and we add 1 to the bottom, so that's why it's x squared. And so taking the derivative of inverse sine, you can use this formula here, make it a lot easier. So u is equaling 10 over x. Take the derivative here, that's going to be all over the square root of 1 minus 10 over x quantity squared. And this is going to be times dx dt, which we're kicking out an implicit value, so that's why we have this here. Okay, now we're ready to plug in. D theta over dt equals negative 10 all over x is 25, it's going to be squared, all over the square root of 1 minus 10 over 25 quantity squared times negative 1. Now we're going to multiply by him at the end because we want to make sure that we use everything, so we're just going to use him at the end. And so now this is going to give us d theta dt is equal to negative 10 over 25 squared all over the square root of 1 minus, distribute that square, 10 squared over 25 squared. And now we realize that here, for those of you who are updated on all the shortcuts that are happening these days, we're going to do 25 squared times 1 and subtract 10 squared, which is called bow tying. So this is what that looks like. Negative 10 all over 25 squared over the square root of 25 squared minus 10 squared all over 25. Now, this might look familiar for those of you who are familiar with the complex fractions. This looks like something you've seen before. You know how to do this. Multiply here, multiply here. So that's what we're going to do here. We're going to multiply and multiply. What this looks like is negative 10 all over 25 squared. And we're multiplying by the 25 up there. We're multiplying by the square root down here. So that's what that looks like. And we have to keep on simplifying now. And so we get 25 divided by 25 squared, knocks out one of these, and we're left with a 25 here. And this equals negative 10 all over 25 times the square root of 525. How do I get that? 25 squared is 625. Subtracting the square root of 10, which is 100. 625 minus 100 is 525. We have to simplify this even further. So this is going to equal negative 10 all over 25. Now we want to plug in, I want to break down this number right here, but we want to get one that we can take the square root of and it'd be a whole number so we can multiply by it on the outside. So we're going to do 25 times 21, which equals 525. And then we take the derivative, or not the derivative, the square root. We take the square root of 25, we get 5, and we can't simplify the square root of 21 any further, so it just tags along. And now we realize that 10 is divisible by 5. So we're going to cross this out, We're left over with 2. This equals negative 2 all over 25 square root of 21. But you know, if you know this, that we have to rationalize, which means we have to get this radical out of the denominator. So we're going to multiply by square root of 21, like so. And this is going to give us negative 2 square root of 21 over 25 times 21, because when we multiply the radicals together, they cancel and we're left with a number underneath. So this equals negative 21, negative 2 times the square root of 21 all over 525. Make sure you don't forget this guy here, multiplying by negative 1. So really, this turns into a positive value. So when you plug this into your calculator, you're going to get that d theta all over dt is equal to 0.017 radians per second. So this is our final answer. We answered the question. We were looking for d theta dt. We found d theta dt. The angle, the rate of the angle changing between the line and the water is 0.017 radians per second. So whether our fisherman is reeling in a boot, a tire, or an actual fish to eat for dinner, we found out how fast he's doing it. Thank you.